Hello everyone and welcome to this video. This is part 3 of the beginner tutorials and we're going to be talking about engines. So follow along as we explore and learn how to make engines. Now, if we pop the hood of this truck, you will see a modular engine. Now, if we go to the workbench, you'll actually find several types of engines. You got your small engine, there's a medium engine, and a large engine. So obviously you see the size difference. And then in addition to these pre-made engines, there's actually modular engine components which consist of cylinders and crankshafts and all that stuff. Now we will be talking about both of them in this video, both modular and pre-made engines, and we're going to be just focusing on the small variant for the purpose of this video, but you can obviously apply this technique to the other types. So a trick is if you select anything, including a pipe or rope or whatever, you can then go over top of these. It just doesn't work with a paintbrush, but if you select cube, you can go over this and it tells you what this node needs. Now you can see that the fuel has kind of this part here, or rather this cowling is sort of off-centered, but I mean, you don't have to memorize that. You just put this over. This is your exhaust, this is your fuel, coolant in, coolant out, air, and of course RPS power. This one has the RPS power here and air here, which is really nice for airplanes. It looks kind of like an airplane engine. And then in the back is coolant in, coolant out, exhaust, another exhaust, and fuel. The reason I'm saying airplane is because your air intake can be on the front here, and you can have your propeller attached directly to this or through a gearbox. Now we're not going to talk about gearboxes so much in this video, but obviously gearboxes are attached to the RPS. Now this video is intended for people that don't know how to connect an engine, so if you do, then this probably isn't the right video for you, or you could follow along and learn something maybe, or just watch for fun. Anyway, here we have the large engine. We have coolant in, coolant out, fuel in, exhaust, exhaust. We got air intake, and then in the back, we have our RPS. If you're familiar with my ships, you'll know that I usually use these for the big ships just to prevent lag from having a bunch of individual components from the modular engine. This is, like I said, a good plane engine, or a smaller ship or boat, or smaller boat, not a ship. And then this is good for cars. Now nothing says you have to use these pre-made engines. You could fully use modular, but understanding the concepts that we're going to be going through here directly relate to what we're going to be doing as the modular engine begins. A basic knowledge of engines is helpful, but if not, I will break it down for you right here. So any engine has an air intake, as you see right here. So the easiest thing to do for our purposes is just put a simple filter right on that. Obviously you can use pipes and have all sorts of things, but we're going to try to make it as simple as possible. So there's your air. Now you have your other node here, which is exhaust. So without having much pipes, you could just make this going up here, and you could put either the fluid port or the exhaust itself, which is this guy. There we go. On this end, we have fuel. So for that, we're just gonna make this turn to the side here, and we'll search up our tank. We'll go with the medium tank and plug it directly into that port right there. Just make sure that diesel's selected. Okay. The last three things are your RPS and your coolant. Now, the nice thing about coolant is if you're in a boat, all you need to do is have this go down like that, and then you just put your fluid ports like that and that. The reason it's not working because we're so close to the ground. We'll move it up a little. So you just plug this in like that, and there you have it. You're sucking your coolant in and pulling it out, and it's just recycling with the seawater. Now these engines do have their own, call it a built-in pump, so you don't actually have to put a pump this is already a system that has a pump. And likewise, you could also put a tank if you want to have as part of this system, and then have it, going out. It'll just make add a little extra bit of water in it. But in this case, in the case of a boat, it doesn't matter. You're just using the cold seawater. Now, if you're not putting it in a boat, obviously you don't want to put air in the system. So what they have to offer for us in this case are radiators. Now, previously there was only this radiator, and it's just a simple, mechanical radiator. There's nothing electric on it. However, since the modular engines came out, we actually have different types of radiators, including, call it this one, and an even larger one for bigger engines. There's also other ways. There's all sorts of heat exchangers, heat sinks. So I'll let you play with that. We're just going to go with the most basic system in this case, which is this guy, which is just a simple radiator, fluid in, fluid out. See, this one here actually has a fan on with a temperature, fluid in, fluid out, electric. So this one's good, but you can have your fan running when the engine's on, or you could have the fan turn on when the temperature reaches a certain criteria. But again, basics is just this one. You just plug it in and that's all. So now we have everything connected physically to the engine except for the RPS. Now in the case of this demonstration, let's just go ahead and put a wheel. Why not? If we put a helicopter rotor, it may want to take off. So a simple wheel can go up there. And that's everything we need in a basic sense. You'd obviously connect this to your drive shaft of your vehicle, to all four wheels or two wheels, or to your propeller on a boat or whatever. But again, like I said, we have this for now. If we press our logic, which we went over in the previous tutorial video, there's only one electric connection here, and that's the electric connection that's gonna start up your starter. But we're gonna go ahead and put a battery. Now with the modular engines, they did release the crank, so you could put a crank on your drive shaft and actually make the engine start via mechanical energy. But in this case, we're just gonna use the battery. Now we're gonna put a simple button, and it's gonna be a push button in this case. Put it here, and then the lever. Now the reason we're doing it like this is not the best way to do it, obviously, keep in mind please, but this is going to give you an idea. Just connect everything electric. It's going to give you an idea of the most basic form of engine. Call it your lawnmower engine. Okay, so imagine lawnmower engine, you pull the cord, that's going to be the equivalent of us pulling the starter here. And then you have your throttle, which when you compress the top lever, that's your throttle, and it kind of shoots up. Or you could have a different lawnmower that actually has a throttle lever. So anyway, we've plugged in now our throttle to this. Just make sure that it's 0, 1, all this stuff. And this button here is our starter. So it's ready to be tested. Now we go over here to our engine. And if we press this, you could hear it kind of starting to turn over. But without throttle, it's not going to take off. Whereas if you pull the throttle up all the way, there you go. Now the wheel's spinning. The engine's redlining, as you can see the RPMs. So we got a working engine. That is your basic form of working engine here. And as you saw, it started up. And as long as you don't cut off the power to it, it's going to keep going. Just did a quick recolor so it's not glaring, but again, starter, and actually there we go, and we can find a spot where the RPSs are not redlining, but regardless, that doesn't matter. We have the working engine now, the wheel's spinning, the engine's going, and you give it more power. So you see that the diesel's getting consumed. your filter is sucking in air, but because we're redlining, it's kind of performing funky. That's okay. Because this system you put to a propeller to whatever, and you make it work. Now you can also limit your power via RPS and your power here, so you don't have to hit the red line. And we're just going to try this with the propeller, pretending we're in a boat here. And we could actually limit the power even at 40%. Now that's not called tuning an engine. I'm not tuning the engine, I'm just trying to make it work. Alright, and it's still redlining, but that's fine. So, ways you can now control this power, because right now it's like your lawnmower. You pull the cord, you compress the lever, and now your grass cutting blade is just going. It's spinning and spin, and once you cut power to it, the engine turns off. So that's not a car engine in a sense that where you turn a key and everything, you've just here pressed a button and you've got your power. So a very simple boat, like a lifeboat, could use this system. You know, you're going to pull the ripcord, and as long as you're giving your boat throttle, it's going. Like a simple, very simple outboard motor. And you can see here now it's off pretty much. Now things you'll want to do in addition to this is you'll definitely want to have a little generator here. In the modular engines it's called an alternator, in real life it's called an alternator, but in this case this item is called a generator, and you connect that to your battery, and then of course you put your propeller or whatever. This just ensures that you're constantly charging whatever it is that you need to be charging. In this case, just your simple battery with your starter, but imagine you have a boat with lights, with screens, with stuff. This generator is going to make sure that it is getting charged. Okay? Also, what you can put is a clutch. Now, something I learned through trial and error is that you'll definitely want to have a clutch. Not on you'll want to have at least a generator on the inside of a clutch. The reason I'm saying that is because if we put this generator on this side of the clutch and remove it from here, if this clutch is not engaged, or if your clutch is sort of pushed in like in a car, and now zero energy is transferring through this, 0 RPS is transferring through it, you will actually have a system here that's just going to redline the engine, and it's going to be a zero load system. So I do, from experience, know that you do want to put a generator, at least one, on this side, and then of course on this side you could put as many as you want. You could have a whole branch of them, and they'll charge all sorts of things, and then you can go onto your propeller. Now how an engine works is obviously the more things you attach to this system, the higher your load. So now your power, your actual power that's transferring through to your propeller is less when you have these 4 generators than if you just had a simple clutch with the propeller. And I'll let you play with these numbers, I'll let you experiment and determine what the best combination is. So now with this thing, what we've done, our reduced power may not even be able to handle it. So we're going to try to turn this on. Oh, of course, our clutch is at 0. So the clutch actually has to be depressed in order for this system to work. Apologies. So we're going to jump here. We're going to add a lever for the clutch, plug it into the battery, and connect it to the clutch. Okay. Now the way that the clutch works, in this case with this at 0, like you saw, this starts up, and check it out, the propeller is not spinning. There's nothing going on to the propeller. It's all just going to this one generator. Nothing's even going to these. But if we release that, we almost stalled it, but here we go. Now everything's working, and it's still even redlining. And if you reduce the throttle to the clutch a little bit, you'll actually get a different amount of power transferring through this. So that's also something you play with. And if you reduce this, you'll eventually get to a level that's going to sort of start to drop the RPS, and you may even stall it out. So if you put way too many things here, if you put a huge generator, for example, or one of the large generators, you may actually just stall this system out. So there's obviously a capacity to what you can put on the engines. Likewise, you couldn't start off. So check it out. If we turn off the clutch now, it's all going to this one. And if we start to enable this, there's actually some power going through, but we're not stalling it out yet. You give a little more power. And then give it, and there you go, it's stalled. So this large generator definitely cannot work with this engine unless you have a super small amount of clutch. So like that's how you can have a large vehicle being operated by a small engine, except you'll just get a very, very small amount of power going to it. Okay, so there we have how a very simple engine system works. And you could use this on your ships or small boats, but now, mind you, this is not a good place or not a good operating system for the controller. You have to in this case, you've just applied power via a push button. You have to have throttle, otherwise your engine cuts out. So now we're going to develop a microcontroller that's actually going to be good to make engines work pretty realistically. Another thing worth mentioning is that be careful when you're putting this air and exhaust. They have to reach an external system. So if you're putting it inside a building, it may not want to work. Give it a shot, you'll learn for yourself. So this is something that has to actually reach out. So if this engine is inside a boat, you have to make sure that these go outside of that boat. So wherever the boat boundary is, you got to extend this until it passes it, and that's where maybe your deck is or whatever. Well, it wouldn't be with the propeller, but you get what I'm saying. So you do want to have them going outside. In this case, because this whole thing is outside, that doesn't really come into play. And then another thing worth mentioning, if you are beginning here, you'll want to put a fluid hose anchor on this little tank here so you could refuel it. Also note that this tank can be a closed system, so you could make custom tanks just like this. And as long as you put a spawner, the fluid spawner in here, and set it to diesel and fully close this. So right now it's not closed, it would not work. But even if we put a window on the end of it, just like that, this system will actually work. So that's just how you make custom fuel tanks. You see that there is liquid inside, it's blue, and likewise your engine will work and fluid will get into the system, as you can see here. Another thing, you see all this exhaust, it's because we don't have a catalytic converter. So you'll definitely want to put a catalytic converter, and see there's two sides to it. One is in, one is out. So in this case we put it down, and now it says exhaust out, which is fine with us. And you put that right up there. These also do limit your RPS, like they will strain your engine if you have 10 catalytic converters in a row. And then this thing, we're just going to go back to how we had it, so keep it as simple as possible, but that is some stuff that you can consider as you're building your engine. Okay, there we have it. And like the hose anchor is pretty important. Okay. All right, now on to the next thing, which is the microcontroller I promised. But before we jump into that, I will cover gearboxes briefly. Now, gearboxes are the only way to make an engine run in reverse. You have to plug it into a button. You have to plug the button to electricity. And in that case, you will turn on this ratio on to be -1, right? Like that. And that means when you've pressed this button here, your engine will go into reverse. Without a clutch, if you don't keep the clutch, if you don't press in the clutch, you will actually stall the engine because you're all of a sudden changing the direction of the power. But anyway, as far as you're concerned here, for the basics, this is the way to make it go in reverse or back up your car or boat or whatever. But that's not the only reason or application of gearboxes. If you change the ratios here, you will actually either multiply or divide the power, the RPS going through the system. So for that, I'm just going to have a quick demonstration here. We're going to take a propeller for a boat, the small one, or even this thruster is fine. We'll attach it here to the top, and I'm actually going to make a copy of this whole system because I'd rather demonstrate with an example instead of just by talking. So we've attached these. Now the only difference I'm going to do here is I'm going to take this gearbox on this one and flip it around. So you see how that one has the arrows facing up and this one here has the arrows facing down. Everything else is identical. And we're going to go ahead and start the engines. We do need the clutch attached here. So I'm going to go ahead and start the engines and see what happens. In this case, and first I'm just going to turn the throttle up all the way on both of them. Okay, we start this up. It's obviously going, and then if I give it clutch power, we stalled it out. Let's try again. And there we go, it takes off. So when you attach something like that, you don't want the clutch to fly in too fast. Otherwise, you'll stall it out. But here you have it. It's working. Now in this case, max throttle. We're going to max this throttle out. Okay. So you can see here they're both operational, which means even with this gearbox the way it is, it's still able to push everything through the system. And the reason why is because I put it on ratio on. So that was not intentional, but you learn through my mistakes. So the only way to change that would be to press this button. Okay, so in essence, what we have going through to both propellers right now is equal power, and it's 1-to-1 power. So it's this off path, and they're both going through that off path right as we speak, and that's it. Okay. Now if we try the same thing we just tried, except do it properly here, you'd have the throttle up, clutch up, okay, throttle up, clutch up, start them up, okay, like we had it, both are identical right now. Now if you press this button, take a look at what happened. We've reduced the amount of RPS going through here. So now we even have more load on our, we're redlining the engine even more. There we go. Because now it's reducing the amount of power that's going through here. Whereas if you press this button, it multiplied that power like crazy. And it's now, so take a look at that. We're either multiplying it or reducing the power. So when the gearbox is facing towards whatever it is you're trying to plug it into, so when it's facing away from the engine, you're reducing the power. When it's facing towards the engine, you're increasing the power. Now, power is the wrong word. It's not really the power that's being increased, it's the torque. Okay? You're increasing the RPS that you're putting through there. So the RPS is the one that's changing. The power of the engine stays constant. Now, this function is good because now at the same RPS, you're actually applying a lesser RPS here. Doesn't really make sense for propellers, but for a tractor or for a truck or something pulling a heavy load, this is actually going to give you the power to keep going, whereas this would just stall your creation out. But this is good for a boat, for example, because in a case of a boat, you now have more power going into the water, whereas this would just make your boat super slow. So that was a very basic and dumbed down version of the gearboxes. You'll still have to do more research and explore, and if you want, we can do a more in-depth exploration of how gearboxes function, but in the case of this video, it's just basic engine stuff. Okay, so lastly, now we said we have the creation of the microcontroller that's actually a better microcontroller than what I have here, which is no microcontroller. You're just pressing a starter. Okay, so for this one, we're going to make a very basic engine microcontroller. Now, if you watched my video for microcontrollers, I always recommend having an empty one, just so you can take it from there and add whatever it is you need. So in the case of what we want here, we want to add a node for throttle, and it's going to be an input. We want to add a node for throttle, which is going to be an output. We want to add a key button, so when you press your key, that's this. We'll call this key. We'll call this throttle out, and this is throttle in. And last but not least, we need engine starter. Now obviously this is a very, very simplified controller, and sorry, here we go, I was talking instead of focusing. This is our starter. So like I was saying, this is a very simplified controller. There's no clutch control, which actually is important to have, but we're not going to focus on that right now. We're just going to have these simple things, and I always line everything up like this at first. So the way you're going to want it is when you press the key, okay, instead of it being here, which would mean your starter is constantly going, your batteries are going to drain. No, you want your starter only to go for a certain amount of time. So what we're going to have is the key is going to force a capacitor, okay? And the capacitor is going to attach to the starter. So the way the capacitor works is it charges up and then it has a discharge, okay? So in the case of what we want here, there is no need for any startup charge, only a discharge. And we could make it for a second, it's fine. Or half a second or whatever. So that's just the amount that you hear the starter going before your engine kicks in. Okay, that's the capacitor. And if we plug this in here, that won't work because you're going to have the key constantly initiating the capacitor. So what you actually need is a toggle to pulse, which is right here. So the way that operates is you're going to push your toggle button, which is in essence your key here. It goes through this, it's going to push this, which activates your capacitor and discharges it for 5 seconds. Okay, that's going to be the proper way for your, well, one of the ways. I'm not going to say proper way because there's hundreds of different ways, thousands of different ways to do this and make it work. But anyway, the next thing is a numerical switch box right here. And the way that this is going to do, it's going to be attached to your throttle out. And then we're going to put your throttle out here to actually control a up and down counter. Now this is a good microcontroller for a boat. The reason I'm saying boat is because in a boat you're gonna give it throttle and you're gonna want your throttle to stay. Now this up and down counter works the same way as if you had a lever in your creation, okay? So I will actually show you how to do it without it first. And the way that we want this to work is if you're putting the key on, then you want your throttle to be on the on path. If you have your key off, there is no throttle to go through. So here it is, super basic controller. It doesn't have an automatic throttle set, and we're just gonna go ahead and call this test and upload it here, okay? So now instead of plugging this into the engine, we actually want to plug this in here and plug this to the engine. So throttle in goes to this controller and throttle out goes to the engine. And now instead of this starter, we're actually going to go ahead and put a key here, just like that. And that's going to be our key button, and this is our starter button. And we plug the electric in there. The only issue that is going on with this controller right now as you have it is that if, well, I'll show you. You start it up, nothing happened because there's zero throttle on the engine. So now imagine you put throttle. There we go. So now the only issue here is that this is working, other than not having to push a starter button, it's not really doing anything to make your engine idle. So to make your engine idle, you'll actually need to have a minimum number going to the throttle at all time. So in the case of just a simple numerical switch box, the way you do it is probably not even in here, to be honest. I would just do it where you set here your throttle has a minimum value of, call it 10%, and a starting value of 10%, and there you have it. So now as soon as your engine is started, because you have 10% throttle, it's idling. Granted, it is kind of stalling out a little bit, so maybe 10 is not where you want it to idle. So you'd have to manually go and find where the right RPS for idling is. And that's just going through here. So the reason why it's either draining, either stalling or not, is because there's power going through the generator. Now you can have other fallbacks in here that I won't get into, but for example, if your RPS, you can add an RPS node. If your RPS drops a certain amount, it automatically kicks on the key sequence again, or it increases the throttle or whatever. So there's many different ways around it. But for now, I'm going to go and show the second system, which was to have the up and down counter. And the reason I'm saying this is because that I use this system in mine, and pretty much it instead of using this throttle here, it's now going to use a seat. So you put a seat here, and now that seat and this WS function is now your new throttle in. Now you're going to have to set this to 100%, because if you keep it on low, it won't work properly. So 100% throttle or sensitivity here. And now in here, you will create a less than and greater than function, and I showed you how to do that in the other video. Okay, so if your throttle is greater than 0, and if it's less than 0, so if it's greater than 0, you want it to go up, right? And if your throttle is less than 0, you want it to go down. So far so good. Then here you connect this to the on path, which means it now switches it from 0 when it's off to this one when it's on, and here it goes to throttle. Okay. Now in this counter, the up-down counter, is where you actually have to do some setting. So what we'll do here is we'll actually set it such that you have an increment of something like 0.009 or 0.1, whatever. That's your increment to which you can increase. Your reset value is 0. Your clamp is enabled, and that clamp is what's going to make your throttle set to whatever it is you need. Your minimum will be 0.1, so 10%, okay? And your max is 1. So now with your throttle set, and your reset could be also the 0.1, it's the minimum. If you spawn this in and go to the creation, and now of course you sit down here, and if you look over here, it says that there's a throttle of 0.1% or 0.1, sorry, on the engine, and if I press W, I'm increasing it. And now I've increased it to 100, and now if I press S, it drops all the way down until it is 0.1. So 0.1 or whatever would be where your engine's not stalling out. So you may need to set that, and that actually is a factor or determined by this guy. Because if you don't have this, it'll stall out. It won't stall out with that. Like if you remove this and just put this, now there's no load until we engage that clutch. So if I turn this, the RPSs will just climb and climb and climb and climb. But this is what I'm saying. It's almost like a runaway engine or runaway diesel engine where the RPMs just keep climbing because there's absolutely zero load. Now if you slowly engage the clutch and increase your throttle, we actually stalled it out. And now here we have it. So this is too much power for it with this current system. But anyways, that's where the clutch comes in, because you have to ease the clutch in order to not stall your engine. Okay? Now, the way I used to play is you'd simply put a 1 on up and a 2 on down. And now you'd have your system where you can sit down. Now this propeller is too much for this engine, but if we just put a regular propeller, let's say, like that, and we go to our engine, turn the engine on, obviously there's no power going through into the propeller, but the engine RPM is climbing, and what you do is now you'd press a combination of W and 1. So you'd give it throttle while giving that, and that's how you'd get the power to kind of go through this. Now actually I did incorrectly put the throttle here, or put the sensitivity. You'd want it to go up fairly slowly, just like a car, because if you stomp a car or pull up off a car, it'll stall. So in this case, you're now adding while adding, and there you have it. So that worked. Like I was just pressing 1 and W, and now we're moving. And then if you want to stop, you hold a combination of S and 2, and then drops down, and this drops down, and now we've stopped giving power to the propeller, and you're only at the bare minimum throttle on the engine. Hopefully that made sense. It's a little confusing, but pretty much now there's no power going to here. This is just residual power that's slowly draining. It's all sitting inside the engine. This clutch is not activated. So this is how you'd bring your boat to a stop. Okay? And then if you want to make it go again, you press your combination of 1 and W, and you're slowly engaging the clutch until it catches. Okay? One mistake I did make is this one should not be a toggle, it should be a push, just like that. Okay? A good way to actually watch how this system works is on this display gauge. And what you do here, after you plug it into power, is connect your primary display to your throttle, and then your secondary display to your clutch. Now the clutch, we found we could actually increase it a little. So now, if we sit down here, turn on your engine, there we had it. It's skipped up to 10%, and now we could increase the throttle, but of course there's nothing going to the propeller. Or we could slowly drag them both up, and it'll catch. And there we have it. And then likewise you bring them down. Now you could try to make the speeds match, and that may be the best place, but it also really depends on the load, meaning what kind of propeller system are you using on this thing. So anyway, that's how you'd make a simple engine without a clutch system, without an automatic clutch, let's say. So you have a manual clutch that you operate. So there you have it. That's how to make a pre-made engine. The same system applies to the medium and large engines. In this video, we're not going to go cover the modulars because they're a bit more advanced, but they use the same idea that you see here. Obviously not in this arrangement. Regardless, hope you learned something. If you made it all the way through the video, stay tuned for more. Comment if you have any comments. Make sure to join my Discord, because that's where I'm talking to the community instead of the comments on YouTube where I kind of just look over them. We have discussions in the Discord. And as always, happy Stormworksing, everyone.